Okay, how are you today? I'm talking to my class like I've just met them, but this is 15 minutes into the class, so a little weird, huh? What are we going to talk about today? Excuse me while I do something here. What we're going to talk about today is a little bit different from what we were talking about before. It's going to be the expansion of a solid. Remember we spoke yesterday and said that solids and liquids will expand if heated, will contract if cooled in a way that's specific for that substance. Remember we said that? So if I heat an aluminum rod, it's going to increase its length, correct? And that length divided by the temperature will be a length per degree Celsius, correct? And we said yesterday that that number is actually a coefficient of expansion, correct? And the coefficient of expansion is going to be a characteristic physical property. You're all right with that? For the length, the coefficient of expansion relative to length, not volume, but length, is alpha. So the coefficient of expansion of aluminum is going to be 24, not 2.4, 24 times 10 to the negative 6th per degree. That negative 1 up there, that means 1 over degree Celsius is the same as degree Celsius to the negative 1. Do you understand that? So that means per degree Celsius. Is everybody okay with that? Nika, you okay with that? Okay. Now, the problem I'm going to do is going to be example 3 on page 139 of problem set 11. All right, I'm going to read it to you. So please take that out. Again, the problem has worked out for you, but I'm going to talk you through it because it looks a little different. Looks a little weird with that alpha in there and some of the other expressions. All right. Ernesto is knitting his wife a sweater in his 18 degrees Celsius air-conditioned living room with a 0.3 meter long aluminum knitting needle. When he decides to knit outside in 27 degree air, Celsius air, how long will the knitting needles expand when Ernesto takes them outside? Well, this is the equation. All right? Yes? Excuse me while I turn around here. Delta L is going to be 3 parallel lines, horizontally parallel means defined as, correct? This is the change in length. And that's actually what we're going to calculate. LO is actually pronounced L naught, and that will be the initial length. It's the beginning length. Okay? And the temperature, right? TF is going to be, what's the final temperature? What's the final temperature? What did I say? 27 degrees Celsius. And the initial temperature is going to be 18. Now, that may seem like normal temperatures, but 27 degrees Celsius is not hot. It's comfortable. 18 degrees Celsius, that's pretty chilly. Pretty chilly. So, air conditioning must be cheap to run wherever Ernesto is, right? All right. So now all I do is I plug in, right? Alpha is here. The change in length is what I'm calculating. The original length is here. The change in temperature is here. Let me reread the problem again. Ernesto is knitting his wife a sweater in his 18 degrees Celsius air-conditioned living room with 0.3 meter long aluminum knitting needles. When he decides to knit outside in 27 degree air, how much will the knitting needles expand when Ernesto takes them outside? So can you plug in? Can we do this? I need you to calculate. I need at least 2 people because I need to verify the answer. So we'll do it right here. Change in length equals the original length, which is what? Oh, I actually didn't put it down, did I? So the original length is going to be 0.3 meters. Is that correct? Yes? Yes. So it's going to be 0.3 meters times 24 times 10 to the negative 6th per degree Celsius.
How do you put in the per degree Celsius? If you don't.
You can go like this.
Oh.
You know, if you don't like that to the negative 1, you can just say per degree Celsius. Okay? And then the change in temperature. So let's just do the change in temperature. It's going to be how many degrees? 9 degrees, right? So what's that going to be? 0.3 times 24 times 10 to the negative 6th times 9. Lana, do you have an answer?
Yes.
What do you have?
6.48 times 10 to the negative 5th.
Jack, what do you have? What is it? I'm in the way? Okay, sorry. That's actually correct, Lana. But I'd like everybody to verify that. Can you calculate that out?
Yeah.
You got it, Jack? Okay. So could you read that for me again, Jack? 6.5, is that okay?
Sure.
Times 10 to the negative 6. Negative 5. Negative 5 what? Meters. Easy? Yes? We'll come back with a little AC/DC. Sounds good? You know? People are kind of falling asleep a little bit. Okay? Yes? Rebecca's smiling. She likes that. Okay? I have teenagers that like music from the 80s. Very weird. That was how many years ago? 30 years ago? Ish? 1983 was 30 years ago? In 1974, that would be saying that I like music from the 40s, early 40s. I didn't. I do now, but I didn't then. A little weird. Rock and roll is much more classic, much more encompassing, isn't it? It cross-sects a lot of generations. People that were older than me who are in their 70s who were listening to rock and roll in the 50s, right? And people who are in high school in 2013 like to listen to rock and roll, don't you? They'll like some really Joan Jett, like I love rock and roll, some real thumping rock and roll. Cool, huh? Yes. Be right back.